Alrighty, so today we're going to spend our time reviewing rules of exponents. Okay, this is stuff that you've learned before, so we're just going to kind of work our way through it and see some examples. Okay, so anytime we're given a term, something raised to a power, we always have a base and we have an exponent. Okay, so the base of a to the fifth is a, and 5 is the exponent. Okay, you have to pay careful attention as to what exactly is the base. Okay, as to what exactly is being raised to the power. You need to use your ideas of parentheses and what we know about order of operations and things like that. Okay, so in number 1, 2 to the 4th, what is the base? 2. Yeah, just 2. What about in 2x to the 4th?
2x.
Just x. Why just x? Yeah, because it's not in parentheses. You have to do the exponent first, and then you'll multiply by the 2. Okay? In number 3, though, what's your base? 2x. Yeah, because it's in parentheses. So it tells you that the power is being raised, that the whole 2x is being raised to the power. Okay, and then what about in negative 2x to the 4th? Negative 2x. Okay, so I challenge you to really take a second and make sure you know what the base is that you're dealing with. Okay? All right, let's review these rules. When you take the product of two terms with the same base, what do you do with the exponents? Add them. You keep the base the same. So what's the base here? 5. And then you add your exponents. So 3 plus negative 1 is 2. So 5 squared is 25. All right, so let's generalize that rule. If we have x to the a times x to the b, keep your same base. What's your base? X. And then what do you do to your exponents? Add them. So x to the a plus b. Okay with that? All right. What do we do when we have a quotient of terms with the same base?
What if the variables were different on the first one and we multiply them?
The variables are different. You can't apply these rules. The bases must be the same for these rules to apply. Okay? So when we have a quotient of two terms with the same base, we're going to subtract. So what's the base in this example? 2. So keep your base and then subtract your exponents. 3 minus 1. 3 minus 1 is 2. So 2 squared is 4. So you keep your same base and then subtract your exponents.
And would it ever be different from top and bottom for the base?
It has to be the same base. All right, when you take a power and you raise it to another power, what do you do with those exponents? Multiply. So 5 cubed raised to the 6th power. Keep your base of 5, and then what do you do with 3 and 6? Multiply, so you get 18. So we kept our same base, x, and then multiply a times b. Okay, a product to a power. Remember last semester, I really harped on the fact that if you've got an addition or a subtraction sign inside your parentheses, you're not allowed to distribute that exponent, right? We had to double distribute instead of distributing that exponent, okay? As long as there is no addition or subtraction inside that parentheses, you are allowed to distribute the exponent. So this just becomes 3 squared times a squared times b squared, which would simplify. What's 3 squared? 9 a squared b squared. We just distribute that exponent to each part of what's inside the parentheses. All right, so xy to the a becomes x to the a times y to the a. All right, quotient to a power, does anything change? Nope, so on both of these you distribute. So this is 3 cubed over 5 cubed. 3 cubed is 27. 5 cubed is 125. So this is x to the a power over y to the a power.
Once you get 3 cubed over 5 cubed, then you just subtract.
Nope, because they don't have the same base. Okay? All right. 0 exponent property. Anytime you have an exponent of 0, what do you know? Equals 1. So 25 to the 0 is 1. X to the 0 is 1. Anything to the 0 power is 1. Yeah.
Is even 0 0 0?
Mm-hmm. All right. Negative exponents. Okay? Negative exponents cause a little bit of trouble. You've got to make sure you're dealing with the base. All right, so there's a couple different ways you can look at this. When you have a negative exponent, you can think about taking the base. What's the base of 5 to the negative 1? 5. You can think about taking the base and taking the reciprocal of it. So the reciprocal of 5 is 1/5. And then the 1 becomes positive. The exponent becomes positive once you flip the base. And 1/5 to the first power is just 1/5. Okay? The other way you can think about this is anytime you have a negative exponent, you can take that whole term and move it to the other part of the fraction. Meaning if it's in the numerator, you can put it in the denominator. If it's in the denominator, you can put it to the numerator. And that changes the sign of your exponent. So I can take 5 to the negative 2 power. Right now it's in the numerator, right? And I can essentially move it to a denominator. So I can rewrite this as 1 over 5 squared. Which becomes what? 1 over 25. You can think of it either way. You can think about just taking the reciprocal of the base and then using the exponent. Or you can think about moving the whole thing to the other part of the fraction. Different problems, different strategies are going to work better for you. You just have to kind of see which strategy works. Okay? So I can rewrite x to the negative a as 1 over x, the whole thing raised to the a power, which is the exact same as 1 over x to the a. These two are exactly equivalent. You can think of it by distributing this a, or you can think about it as taking this whole thing and moving it to the denominator. Okay? We okay with that? All right, look at the next one. 3/5 to the negative third power. What are we going to do with that 3/5? Yeah, we're going to flip it. So this is going to become 5/3 raised to what power? Positive 3. So then we distribute. So 5 cubed is, and 3 cubed is 27. So how could I rewrite my rule?
Y over X.
Yep, y over x to the a power, which is the exact same as y to the a power over x to the a power. Okay? A's. Sorry, my A's kind of look like 9s. All right, let's give it a try. Negative 5 raised to the negative 2 power. What are we going to do? Okay, negative 1/5 squared, which is positive 1/25. All right, what about 5a to the negative 2 power? Good. 1 over 5a. That quantity is raised to what power? 2. So it's going to be 1 over 25a squared. Uh-huh. Sorry? Because you're squaring all of 5a. Okay? Other questions?
So, is it a negative exponent property for the fifth one?
I'm sorry?
I'm confused on what property which an exponent rule chart is from 5 and 6.
The negative exponent property. Okay, number 7 says 5a to the negative 2. What is the base of that negative 2 exponent?
A.
Just a. So is the 5 going to be affected at all?
No.
No. So I'm going to keep my 5 the same. And what's going to happen to the a to the negative 2? Good. It becomes 1 over a squared. Which becomes what? So 5 times 1 over a squared. And how does that simplify? Good. Okay. One other way you could think about this is, remember I told you that another way, excuse me, thank you, that another way to make that exponent positive is to move it to the opposite part of the fraction. So right now, at the beginning, a to the negative 2 is in our numerator, right? So in order to make that exponent positive, I can move it to the denominator. So I keep 5 where it is, but I take a to the negative 2, and I move it to the denominator. Gets you to the same place, right? You're going to have to remember that rule because a simplified a simplified expression will never, ever, ever have a negative exponent. Have to move it up or down, okay? All right, let's flip to that. Go ahead and try 8 and 9 for me, please. All right, what do we do with 8?
3 over.
Okay, we write this as 3/2 raised to what power? Positive 2, so that gives us 9/4. Everyone okay with that one?
Yeah.
Okay, and number 9, you got to break it down and work with your coefficients and then work with each variable. So start by taking 3 times negative 4, and what do we get?
12.
And then you take z to the 7th and multiply it by z squared. Z to the 9th power. Everyone okay with that one? Okay. Let's look at 10. Y z cubed over z to the 5th, the whole quantity cubed. Now, my recommendation on a problem like this is to simplify the inside of the parentheses first. Then deal with the third power. Okay, so I have y z cubed over z to the 5th. What part of that can be simplified? Z cubed over z to the 5th. So I've got the same base, and I'm dividing. So what do I end up doing with 3 and 5?
Subtracting.
Okay, so I get 3 minus 5, which gives us what? -2. So where am I going to move z to the -2 power? To the bottom. So this would give us y z to the -2. But I can't have that negative exponent, right? So I'm going to move z to the -2 to the bottom. So it's going to become y over z squared. A good trick to remember, anytime you have division with the same bases, look at your exponents, 3 and 5. Where is the bigger exponent, in the numerator or the denominator? That denominator. So that means your z needs to end up in the denominator because the higher power is in the denominator. Does that make sense? Okay. So we're going to take y over z cubed now, or sorry, z squared, and cube it. So what's that going to give us? Y cubed over z to the 6th. Questions on that?
You can't simplify because it's not on the same page.
Correct. You can't simplify that any further because you don't have the same base. All right, let's look at 11. What do you think we need to do first? Okay, either of those options is fine, to flip the base or distribute the -3. That's what's cool about these types of problems is there's not just one path to get you the right answer. It's kind of whatever clicks in your head first. Same idea as if you go down a path and it doesn't really work, start again, okay? I would flip this fraction first. That's just kind of what I would end up doing. But it would be okay if you decided to distribute first. So I'm going to rewrite this as 1 over -2a cubed b, all of that raised to the 3rd power. Did anything about my base change? No, just the location, right? I just moved it to the bottom. But no signs changed on anything. Okay? So this becomes 1 over, what are we going to do with this cube now? Yeah, distribute it. So -2 cubed is -8. -2 times -2 is +4. Times -2 is -8. A cubed times a cubed cubed, a to the 9th. And then we would have b cubed. I have no negative exponents, so I'm good to go.
Could you, every time like you show something like the other way,
What do you mean the other way?
like distributing first?
If you chose to distribute this first, you would have -2 cubed, or sorry, -2 to the -3rd power times a cubed to the -3rd power times b to the -3rd power. So you either would need to flip all of these individually and then distribute this 3. So this would be -1/2 cubed times 1 over a cubed times 1 over b cubed. So it's the same thing, just kind of split up with parentheses. You're going to end up with the same thing, -1/8 times 1/9 times 1 over b cubed, and then multiply them all together. Okay? All right, look at 12. What must we do first?
I multiplied distribute the square.
Okay, the first thing we have to do, guys, is square it. Notice that this power of 2 only goes with this second base. So before we can multiply it by this first expression, we have to square the second expression. Does that make sense? So we have to do the exponent first. Now, as far as the -3 goes, you can go ahead and move it to the bottom and then square and multiply. That's totally fine. Or you can do it at the end. Doesn't matter. Okay? I kind of leave it till the end, but it's up to you. So I'm going to keep my 3x squared y. And I'm going to go ahead and square the second term. So 5 squared is 25. X to the 4th squared is x to the 8th. And y to the -3 squared is y to the -6. Okay? Now I'm going to go through and multiply. You can move your negative exponent now, or you can wait till the end. Up to you. 3 times 25. X squared times x to the 8th. And y times y to the -6th. Yeah, y to the -5th. But can I leave my answer like this? No, because I have a negative exponent. So I have to rewrite this as 75 x to the 10th over y to the 5th.
Will the x
Who started that question? I did. Yeah.
That's enough.
Oh, okay, cool.
wait, so what's the difference between like power to power and product? Is it just like if there's like power on the outside of the face too?
What's the difference between
Like multiply
this one and this one?
Yeah. Like x squared times x squared, or like x squared and like
So if it's x, if you're multiplying items with the same base, you add their exponents. But if you're taking one term and raising it to another exponent, then you multiply the exponents. Does that make sense? Okay. Okay, let's look at 13. What's true about our terms in 13? They have the same base. So anytime we multiply two things with the same base, what do we do with the exponents? Add them. So this is going to be 3 to the 6/5 plus -5/3. Okay? In order to add these fractions, what are we going to need to do? Common denominator. What denominator should we use?
15.
Okay, 15. So this is going to give us 3 raised to, I'm going to multiply this top and bottom by what? 3. So I'm going to have 18 over 15. And then I'm going to go ahead and just write this as minus. Is that okay with y'all?
Yeah.
Minus. Multiply the top and bottom on this one by what? 5. It's going to be minus 25/15. So 18/15 minus 25/15. 3 to the -7/15. Can I leave it like this? No, why not?
Because there's a negative.
Good, you have a negative exponent, so what do we need to do? Okay, so what do we flip?
1/3.
So you have 1 over 3, and then this turns into 7/15. You can also write this as 1 over 3 to the 7/15. Either of those is acceptable.
But on the first one,
Which first one?
like the top, because you have the two answers.
Yeah.
On the top one, I don't.
easier?
Yeah.
Sean?
I did it where you do like 3 to the 6.
Guys.
I did it where you like take 3 to the 6 and divide it by 3 to the 5th, and then multiply that by 3 to the negative 5th times 3 to the 3rd. And then I got the wrong answer. I don't know. Like why that doesn't.
I'm going to have to come look at that in a sec because I'm not following it. Okay? Is that okay? All right, let's look at 14.
Oh my gosh.
What are we going to have to do with all those exponents?
Whoa.
We're going to have to multiply them. These are powers to powers. So we multiply them. So this is a to the 3/2 times 1/9 times -12. Could I write it as -12 over 1?
Yeah.
Okay. So you can multiply across the top and the bottom. Sometimes to make your lives easier when you're doing this by hand, remember that you can cancel when you're multiplying fractions if you have things that reduce over the top and the bottom. For example, 3 goes into 3 one time, but 3 goes into 9 3 times. I just reduced 3 over 9. Okay. You could also reduce 2 and -12 or 3 and -12, and you can keep reducing to make your life easier. Okay? So multiply all the way across the top. 1 times -12. -12. 2 times 3 times 1. 6. So this is a to the -12 sixths. What does 12 sixths reduce to?
2.
So this is a to the -2. Can I leave my answer like this?
No.
So I have to rewrite this as
1 over a squared.
1 over a squared, or you can write it as the quantity 1 over a squared. Questions on that? Okay. What I need you to do now is get out a scratch sheet of paper